Hello everyone, this is the continuation of the previous video. We were doing chapter 1, understanding numbers. We've done a bit of detail in terms of calculations and types of numbers and so on. Today what we're going to talk about is prime numbers, factors and multiples, and then more ideas about it. Okay, so what are factors of a number? Factors can be multiplied together to make the number. For example, 1, 2, 3, and 6 are factors of 6. Basically, numbers that completely divide another number are called factors of that number. Okay, so 6 has the factors 1, 2, 3, and 6. 8 has the factors 1, 2, 4, and 8, and so on. Okay, multiples of a number are the result of multiplying the number by any of the natural numbers. For example, 6, 12, 36, 600 are all multiples of 6. Okay, earlier on in your earlier grades, you must have studied what we call tables. And you would say the table of 6 is 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and so on. So 6, 12, 18, 24, 36, 42, and so on are multiples of 6. Okay, a number can be divided by another number without leaving a number and is said to be divisible by that number. For example, 36 is divisible by 3. This is the same definition as the factor of a number. Sometimes you are told about divisibility, and that's what I want to emphasize here. Factors. Okay. Okay. Then what are prime numbers? Prime numbers are natural numbers, so they're counting numbers that have exactly two factors, one in the number itself. Okay. So what are the prime numbers then? First prime number is 2. 1 is not a prime number. Remember that. All other prime numbers are odd. The only even prime number is 2. Remember that as well. This is going to come in handy later on. Okay. Write a list of all prime numbers. So you know that you need to only check what only odd numbers. Even numbers cannot be prime except 2. So 21, is that a prime number? You have to count the number of factors. No, 21 has a lot of factors. It has 1 as a factor, 3, 7, and 21 as well. So 21 is not a prime number. Let's check 23. I don't know if 23 divides with anything. So 23 is a prime number. Okay. Then let's go on to 25. 25 is obviously 5 into 5, so that's not a prime number. 27 is also not a prime number. 29 is a prime number, so 29 is here. Then 31, 31 also divides by just by itself, so 31 is a prime number. 33 is certainly not a prime number, and 35 is also certainly not a prime number. So in this category, you have three prime numbers. Remember that there's no pattern to it. You could have, you see, this was a distance of just 2 units. This was a distance of 6 units. Depends strictly on the number of on the range that you've been given. Okay. What are squares and square roots? You studied previously that these are called squares and square roots. A square number or a perfect square is obtained by multiplying a number by itself. A square root is a number that can be multiplied itself to make another number. Okay, so it's about putting a square root or not putting a square root. It says from the list of numbers, choose a perfect square. Okay, so you need to remember that list. 1 square was 1, 2 square was 4. So I can see 4. Let's write that down. Okay, then there was 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36. So I see that too. Then I don't think there are any other squares inside this. 125 is not a square, 125 is a cube. Okay, so if I ask you what's 5 cube, you will tell me that's 125. What is the square root of 49? Square root of 49 should be, it's the square of 7. So 7 is the square root of 49. 6 square is 36. Okay, and root of 25 is 5. Okay, any number that forms a pair is called a square or a square root. Okay, now the important part of the today's video is this prime factorization. Okay, when you break up a number into its factors, there are various ways of doing it. I'm going to demonstrate to you in a bit how I list down the factors. But let's first talk about prime factors. What are prime factors? All natural numbers greater than 1 are not prime numbers, can be expressed as the product of their prime factors. So any number can be broken down into the product of its prime factors. For example, the factors of 20 are 1, 2, 4, 5, 10, and 20. Of these factors, only 2 are prime, namely 2 and 5. Okay, so 20 can be expressed as 2 times 2 times 5. Okay, that's important. 20 has now been expressed as a product of its prime factors. Okay, this is called prime factorization. How do you come up with this? Now, earlier on in your early grades, you've probably learned something called this. You've always called it the LCM or the HCF or whatever the case may be, but actually, this is prime factorization. Okay, what that means is that you start dividing by the smallest number that you know. So you start dividing by 2 if it's divisible by 2. You divide again by 2 if it's divisible by 2. So that gives you 50. You divide again by 2 because it's divisible by 2. So 25. It's no longer divisible by 2. So you think of the next prime number, that is 3. This is not divisible by 3. This is not divisible by 3. So you move on to the next number, that's 5. Next prime number that you know, 5. 5 times 5. 5 times 5. 5 times 1. Sorry. Okay. So 200 can be expressed as 2 times 2 times 2 times 5 times 5. Or in simpler words, 2 cube into 5. So this is called prime factorization. Okay. You have to remember this. I'm going to build up on this in a bit. The next one says list all the factors of 18. So what are the factors of 18 that I can think of? Now I could start making a list directly. I find it easier to list down factors like this. So 1 into 18 is 18. I listed down two factors of 18, that is 1 and 18 itself. Okay. And then just 18 divisible by 2. So 2 into 9. So I've got two more factors now, 2 and 9. Then 3 and 6. Okay, it's not divisible by 4, it's not divisible by 5, and 6 into 3 is a repetition. So what I've ended up with is a list that gives me all the factors 1, 2, 3, 6, 9, and 18. These are all factors of 18. Okay, so that is how you make a list of factors of any number that you want. List the factors of prime factors of 18. So that's simple. 1 is not a prime factor, 2, 3, and that's it. Okay, write 18 as a product of its prime factors. So you do this prime factorization process and say that 18, 2 times 9, 3 times 3, 3 times 1. This becomes 2 into 3 square is 18. There's three multiples of 18. So 18 times 1 is 18, 18 times 2 is 36, 18 times 3 is 54. Those are the multiples of 18, the table of 18 that you've done early in your life. Okay. Then there are two other things that you probably already know about. One is called the highest common factor, and the other is called the lowest common multiple. Okay. The highest common factor of two or more given numbers is the highest number which will divide into both all of the following numbers without leaving a remainder. For example, 3 is the highest common factor of 9, 12, and 15. Now, I understand that some of you have already done the process where you find the highest common factor by putting it into a prime factorization and dividing, and I'm going to do that in a bit. But here the question is not directly asking me to find the highest common factor, it's asking me to list all the factors of 30. So I'll start making a list. 3 into 10, it doesn't divide with 4, it divides with 5, 5 into 6, and then 6 is to 5 is a repetition. So 1, 2, 3, 5, 6, 10, 15, and 30. Okay, similarly, I make a list for 20. 1 into 20 is 20, 2 into 10 is 20, 3 into nothing, 4 into 5. So 1, 2, 4, 5, 10, and 20. Okay, from your two lists, find the common factors of 20 and 30. So what are the common factors? 1, 2, 5, and 10. If I now ask you what's the highest common factor, what is the highest common factor. Without doing any other process, what you can tell me is that the highest common factor is going to be 10. I can see that in the list. These are the common factors. What is the highest common factor that's in the list? Okay. Now, uh, another way of doing the highest common factor is something that you've done early on in your life. What you do is you make this prime factorization process. You want the highest common factor of 20 and 30. So what you start doing is you start dividing by 2, the smallest prime number that you know. So 2, 10, and 15. Okay. Now you don't end up dividing by 2 again. You look for factors that that are common to both. That means that they're going to divide both 10 and 15. So 2 is not going to divide any further. 3 only divides 15. 4 doesn't divide any of the two. 5 is what I'm looking for. So 5 times 2 is 10. I actually didn't have to look at 4 because it was already 2. 2 was already done. 5 times 2 and 5 times. Now, if you're calculating the HCF, that's where you stop. And you say that the HCF is these numbers multiplied together. So 2 into 5, that gives you 10. I'm not doing the LCM right now. I'm using the process of prime factorization to solve for the highest common factor. Okay, and that's what you need to understand. Okay, then example 18, written as a product of prime factors 168 equals to 2 cube into 3 into 7. Express 140 as a product of its prime factors. Okay, we know how to do that. I'm going to take this up. 2 times 70, 2 times 35, 5 times 7, and 7 times. So 140 can be expressed as 2 into 2 into 5 into 7. 2 square into 5 into 7. Okay, let's just find the highest common factor of 168 and 140. Now I could do this process. Okay, but I'm going to write down some rules now that I want you to remember. 168 and 140. I could do this process and start with 2 and say that this becomes 84 and this becomes 70. There's another possibility, 42 and 35. Now I see 7 as the only possibility. I can't divide any further. So 2 into 2 into 7 should be my highest common factor. Now, how do I do this? By just using my prime factorization. I'm going to write a rule here. Using prime factorization of 168 and 140, take the lowest powers of the common factors only for the HCF. Okay. What that means is that you look at both prime factorizations here and you say, what are the common factors? The only common factors are 2 and 7. Okay. I have 2 cube and I have 2 square. What is the lowest power? So I'm going to say 2 square. Between 2 square and 2 cube, which is the lowest power. 2 square is the lowest power, so I take 2 square. 7 and 7 here, 7 power 1 and 7 power 1, they're both the same, so they're both common. So 2 square into 7, that was also my answer from this process. That is also the answer from the rule that I've just created for you. So 7 into 4 is giving me 28. So 28 is the highest common factor. It's a number that can divide both 168 and it can also divide 140. Okay, and not leave a remainder in the process. Okay, so that is a typical past paper question that you can see. It's there on the board for you. Example number 13. There is a third part to this as well. Let's talk about the third part. Find the smallest positive integer n such that 168n is a square number. Okay, so 168 is already there for you. What n means is that it's simply multiplied by n. So this is 2 cube into 3 into 7. into n. Now remember that first thing that you need to do is write this out in pairs. Okay. What a square number is, it's a perfect square, which means that every number has a pair. So for example, when I say 16, it can either be written as 4 into 4, or it can be written as 2 into 2 into 2 into 2. Okay. Every factor that I write down has a pair. If I write down in terms of twos, it has a pair. If I write down in terms of twos again, it has a pair. For square numbers, every number must have a pair. This has a pair. Okay, 2 has a pair. But this 2 is alone. So n must have a 2 in it. If I'm multiplying by something and I want to make a square number out of it, then n must have a 2 in it. Similarly, 3 doesn't have a pair, so it must have a 3 in it as well. And it must have a 7 in it as well. For each number to have a pair. Okay, which is why 16 is a 16 is a very good example to demonstrate this concept. So when you have square numbers, every prime factor must have a pair. Now I can tell you that if you give me an answer in 7 into 3 into 22 is 42, I'm telling you that if you multiply 168 by 42, you are going to end up with a square number, and I'm going to show this to you on my calculator. Okay, let's I take you to my calculator and tell you that 168 multiplied by 42. Now you don't know what this is, the square of, so you put a root on it. You see, it's the square root of 84. I could also have told you this manually, but right now what I'm trying to show you is that it's just a square number, and I just need you to know the value of n in this matter. Okay, this is a typical past paper question that you should be aware of. Okay, this question was about factors. Okay, highest common factor and so on. Now let's talk about in the same case, there's a question about LCM. Okay, let's talk about that. Okay, the lowest common multiple of two or more given numbers is the lowest number which is a multiple of both or all given numbers. For example, 18 is a multiple of 2, 6, and 9. Okay, that's fine. We know that. Okay. Um, let's find out the LCM process manually now. List the four numbers, four multiples of 30. So that's 30, 60, 90, and 120. 30 times 1, 30 times 2, 30 times 3, 30 times 4. This is the first five multiples of 20. So 20, 40, 60, 80, and not including 20. Oh, okay, not including. Let's write down one more. Okay, from your list, find any common multiples. What are the common multiples? I can see that the common multiple is 120 only. Okay, from your two lists, find any common multiples. Let's look at common multiples 60 and 120. Which of these is the lowest common multiple? Okay, which of these is now let me ask you a fourth question. Find the lowest common multiple. You can tell me that out of your list, the lowest common multiple is 60. Okay, I can see that from here. If I asked you to find the LCM of 30 and 20 directly, what would you have done? You would have taken this prime factorization process. This is something that you do in your early years. I'm just recapping it. So you divide by 2 first. Okay, you keep dividing by the common numbers that you have. So then you divide by 5, 5 times 2, 5 times 3. Okay, then you also divide by the uncommon numbers. So you say 2 times 1 is 2 and 3 times 1 is 3. What is the LCM then? The LCM is 2 into 5 into 2 into 3. That should give you 60. Okay, that is how you found LCM early on in your life. This question is just showing you what the LCM really means. Okay, now how is this tested on the exam? Without a calculator and with a calculator as well sometimes, but mostly without a calculator. So let's see, express 154 as a product of its prime factors. So I just need to do this. The step is always this. 2 into 7 is 14, 7 is 14. Hence divides by 7 directly and 11. So 2 into 7 into 11. When I'm asking you for the lowest common multiple, so I go back and do this again. So it doesn't divide by 2. Let's take a bigger number this time, 7. So 7 times 2 is 14, 7 times 7 is 4. I don't have any other common multiples that I can think about. So 7 times 1 and 2 times 11 and 11 times. So the LCM of this is 7 into 7 into 2 into 11. Okay, that's quite a big number. That's, I can multiply this for you. 7 into 7 is 49, 49 into 2 is 98. 98 into 11 is easy to do. Okay, 1078. There's a trick for multiplying by 11. You might see this on a different video in my channel. You can go back and scroll through that. So 1070. Okay, that's the lowest common multiple of 154 and 49. You can get a question like this on the exam as well. Or you can get a question that asks you for a more complicated idea. I'm just seeing how many more questions I have. Not a lot. So 4 more questions. Let's do this. Okay. Written as a product of its prime factors is this. Then I need to write 108 as a product of its prime factors. So let's do this. 08, 2 times 54, 2 times 27, 3 times 9, 3 times 3, 3 times 1. So 108 can be written as 2 square and 3 cube. Let's just find the lowest common multiples of 108 and 360. Give your answer as a product of its prime factors. I can do that. I know how to do this 108 and 360 and put it into that. But like I wrote down a rule earlier for you for the HCF, I'm going to write down a rule for you. Using prime factorization, take the highest powers. Now, previously we were taking the lowest powers. Highest powers of both common and uncommon factors to find the LCM. Okay, what that means is now you start looking for both the common and uncommon factors. Let's look at the common ones first. 2 is common. What is the highest power? 2 cube. 3 is common. What is the highest power? 3 cube. That's coming from 108. And what is the uncommon factor? That's 5. So 5 power 1. Okay. So that is the LCM of 108 and 360. Had I done this, you would have pretty much seen the same answer. Okay. I gotta do this for you and show this to you. So I keep dividing by the common numbers first. I run out of common numbers, so I divide by the uncommon numbers now. 3 times 3, 3 times 1, 2 times 10, 2 times. I think I have an extra 2 somewhere. It's 360 written correctly. 360 is written correctly, so I made a mistake somewhere. Oh, that's supposed to be 90. So that's another common factor. Then 3 and 10, then another 3, and then 2 and 10. Okay, that gives you 2 cube. That's here. That's 3 cube. That's also here. And then 5. Okay. Now what I want to do is find the smallest positive integer k such that 360k is a cube number. Okay, let's see what 360 is. 360 is 2 cube into 3 square into 5. And now I'm multiplying it by k, so I write multiply by k. When I say that it has to be a cube number, that means every number has to have a group of 3. Let's break this down a little. 2 already has a group of 3. How many 3's do I need? I need k to have 1 3 in it so that it makes a group of 3. Okay. Similarly, how many 5's do I need? I need 2 5's. So I need k to bring in a 3 and 5 square. That means I want it to be 75 in order to make 360k a cube number. Like I showed you earlier, it's going to give me the same results from a calculator. I take the cube root and it's going to come up as an integer answer. Okay, so a very typical question on the past paper. You can see that these are all past paper questions. You should be able to do this. If you are an IGCSE student, you would probably find these questions. Different in terms of doing it without a calculator, but that's the bottom line, that you need to be able to do these questions without a calculator. Okay. Then express this as the product of its prime factors. Now it's going to get a little challenging from here. Okay. These last few questions are a little challenging, and I'm going to try my best to explain these to you. So 99, 3 times 33, 3 times 11, and 11 times 1. So 99 is 3 square into 11. Okay, find the smallest possible integer value of n for which 99n is a multiple of 4. So I want to find a number that's also a multiple of 24 and I want it to be smallest. So technically I'm asking you to find the smallest possible integer value of n, the multiple itself, such that 99n is also a multiple of 4. Okay. If I was talking about LCM, like I wrote down the rule earlier, can we have prime factorizations for both? Let's talk about prime factorizations. Okay, so 24 can be written as 2 cube into 3. Now, if I ask you that I want 99 and 24 to have a common multiple, what will that common multiple be? We wrote down the rule earlier. We said the highest powers for both the common and the uncommon factor. So what's the common factor right now? It's 3. What's the highest power? 2. What is the what are the uncommon factors? 2 is an uncommon factor. What is the highest power? 2 cube and 11. Okay, so that is the LCM of 99 and 24. If I write 99n, okay, and I say that 99n is basically 3 square into 11 into n, then what I can tell you is that if I want to multiply 99 by something and I want it to be equal to the LCM, I want it to be equal to a common multiple, because I want it to divide by 24 as well. Okay, I want it to be a multiple of 24 as well. So I need to make this equals to my LCM. Okay, because 99n has to be smallest and has to be an LCM of 99 and 24. Okay, so 19, so I write down 3 square into 2 cube into 11 is equals to 3 square into 11 into n. Okay, I think that's a pretty simple answer in terms of getting to this. So 3 square cancels out with this. I can actually move them to the other side and show this to you easily. Although we haven't done canceling and things like that, we've done them very briefly. We'll do them in detail later on. 11 cancels out, 3 square, n is 8. This is a typical past paper question. You should remember what this means. Question simply means that I want 99n to become equal to the LCM of 99 and 24. Okay. Okay. The largest integer, which is a factor of both 294 and 784. So, what is the largest integer? I want the HCF. So, I follow my rule. It's the lowest power of only the common factors. So, 2 power 1 and 7 squared. That gives me 98. Then I want the root of 784. Now, I don't know roots so far, but I know that 784 can be written as 2 times 2 times 2 times 2 times 7 times 7. Okay. Now remember that I told you that whenever you are square rooting something, that means every number should have a pair, and when they make a pair, they combine into one, become a single digit, and then come outside. So this is going to be a pair of twos that comes outside. There's going to be another pair of twos that becomes a single two, and there's going to be another 7. 2 into 2 into 7 is going to be the square root of 784. Okay, I am assuming and hoping that you've done these square roots before. If this was cube root, I would make groups of 3, combine them into 1, and bring them outside like that. Okay. Press 500 as a product of its prime factors. I think that's the last question for today. It's been a slightly long class. Okay, so that is 500 into is 2 square to 5 cube. Okay. Now find the values of p and q. This is a separate question. This should be comma here that's missing. Let me just put that down for you. There are two separate pieces of information. One is about m and one is about n. What happens when m is getting multiplied with n? The simple idea is that you add the powers. Okay. So this is going to become 2 power 4, 5 and 3 power 4. So p is equals to 5 and q equals to m divided by n. I think this is a wrongly placed question. This should have been in indices. I have wrongly placed here. So I'm going to change that, and you will probably see that in indices later on in a different topic. This has nothing to do with LCM and HCF. I haven't taught you how to manipulate powers, so I'm not going to do that in detail right now. Uh, but that's the end of the um, video for today. I will be back with another video in the next class. Thank you for watching.